My name's Tim Seeberger, and this is Raz Class. I like to talk about deaerators like it's a cold beer or a beer. So if you can imagine having two beers, and one of the beers is cold and one of the beers is warm, and you pour those beers into glasses, that warm beer foams over, right? So we know that as the temperature of a liquid warms up, it reduces the ability of that liquid to hold on to dissolved gases, or hold on to dissolved gases. That's really what a deaerator works, is we're warming up that water as much as possible in order to drive off those dissolved gases. So how warm can we warm up water? Well, all the way to the boiling point. And so the boiling point, also called the saturation temperature or the saturation point, is 212 degrees at atmospheric pressure. But typically we run a deaerator at 5 to 7 psi, kind of depending on the brand, depending on the manufacturer, what temperature they want to run at. Some plants will run it at 10 psi, but usually we're in that 5 or 10 psi G range for a deaerator. And that gives us 5 psi of differential pressure across that deaerator vent to push those non-condensables out. Now there's a second way that the deaerator works, and that is agitation, right? So if I have two beers and I take one of them and I shake it up, and then I pour those two beers into a glass, that shaken beer is going to foam over. So that agitation, along with that temperature, drives dissolved gases out of solution in that liquid water that's coming into the deaerator. So agitation is achieved in a couple of ways. You know, common deaerators would be spray type or tray type, or like a packed column. So a spray type deaerator is just like a sprinkler head at home, right? So you put a sprinkler head on the lawn, that sprinkler is going to atomize that water in the spray head. That nice finely atomized droplet of water is being sprayed into a deaerator that's full of steam. And so as it runs into that steam, it's going to heat that water up all the way to its boiling point before it drops into the storage section of the belly of the deaerator. But as you can imagine, just like if I put the sprinkler in the yard, if I just barely crack that valve open, instead of having a nice fine mist that waters a whole section of the yard, I'm going to end up with just kind of one little lazy stream going out the side. Well, the same thing can happen in a deaerator. If we try and turn it down further than that particular deaerator design is supposed to be turned down, we don't really get that nice fine atomization. What we end up with is, you know, a couple of little lazy streams, and those big fat droplets drop straight to the storage section. They don't heat up all the way to the saturation point. And so because of that, we're not agitating and we're not heating. So we're going to end up with water that's not properly or fully deaerated. The next type would be a tray type. And so the atomization and heating comes through spraying that water, still probably some kind of a sprinkler head or something to kind of spread that water out. But we're going to let that water drop down through trays in the top section of a deaerator. It looks kind of like a steam dome, like an old locomotive. As that water drops down through the trays, then that water and the trays, it's all heated by steam. So it's going to have plenty of time to kind of drip, drop, and be agitated and be heated all the way up to that saturation point. So similar in that it's agitation and temperature, but a little different approach. Packed column, much the same as a tray type. We're going to let that water drip down through the packing and heat it up. So symptoms, and this is the real big thing to remember for operators, or if you want to know, well, gosh, is my deaerator working right? Does the temperature in the storage section agree with the pressure on the steam dome? So like I said, typical is maybe 5 psig in a deaerator. So if we have a deaerator running at 5 psig, then the storage section of that deaerator should be 227 degrees, right? Because 227 degrees is the boiling point of water under 5 psig pressure, right? Kind of like that pressure cooker on the stove at grandma's house. If we go to 7 psig, then we're somewhere around like 230 degrees, okay? But we want to see the pressure in the steam dome agree with the temperature in the storage section. If that temperature is too low, we may not be getting the atomization that we need to heat that water up all the way, okay? Or it's possible that our pressure gauge is off, right? So when we see a disagreement between the pressure and the temperature, then we start to investigate further, right? So I was at a plant last year where we had a temperature and pressure that agreed at 227 and 5 psig at the deaerator, but then over at the economizer to the two boilers in the system, they showed 212. So what we were able to find out was we had a temperature gauge that had drifted. And we were able to cross-check that with other temperature gauges. So it's important that as we're looking at this, we're using all the different gauges and transmitters around the system to say, does everything agree? Does this all make sense in kind of the larger picture? I was at a different facility where they had a low temperature. Maybe it was like, I don't know, 215 to make it up. But then the pressure gauge showed 5 psi. Well, when we went up to the upper platform to look at this deaerator, we found that the pressure instruments came down about 6 feet from the top of the deaerator. They had this static line that was full of water. And so they thought they were reading a pressure of, 5 or 7 psig on the steam dome, but actually they had, several psi of static head on top of that pressure gauge. And so they weren't getting a true reading. Once we made the adjustments for that static head, then now all of a sudden their numbers made sense and started to agree on saturation. And so then at their next shutdown, we moved that pressure gauge. So there's just a few kind of things to think about, kind of how they work, a couple of simple things you can do to troubleshoot or to try and make sense of your deaerator. And then the last thing I would say is if you're unsure, talk to your chemical treatment provider. They can do what's called a dissolved oxygen test, and they can kind of give you a report card of that deaerator and how it's working. So if they do a little chemistry set work, they can tell you if it's carrying over a lot of oxygen or not. Or they can say, hey, based on the way your system runs, you're using too much sulfite, and so you have too much oxygen coming through. Or they can get a really fancy electronic meter and read that pretty accurately, but that can get kind of spendy. So work with your chemical treatment provider. They can be your advocate. So if you have any questions or comments about deaerators, if I said something wrong, leave it in the comments. If you want to know more, leave it in the comments, and we'll try and find some answers for you, or reach out to us at sales@rasmec.com. Thanks a lot.